once you close this circuit, so for part A, where are the charges going? This is going to load up. It's going to begin to load up negative because it's connected to the negative end of the battery, right? This one's going to begin to load up positive because it's connected to there. Now, of course, these two things act as what that we talked about? Resistors. So they're going to resist the flow of current that would allow this capacitor to charge up. So it's going to take some amount of time to do that. Then skip, okay. Then repeat A for instant when the capacitor is fully charged. Oh, okay. So they also show us that RB is greater than RA. Right? So this resistance is bigger. So what will happen is when you initially turn this on, there's going to be, well, okay, you decide, right? If there are two turnstiles that will allow you to get to your goal, to the ride, and one, well, let's say there's two gates to go into the ride, and one costs $5 and one costs $2. Which one would you go through? Obviously $2. So most, let's say that what's going to happen is the negative charges are going to leave like this, but there's going to be more negative charges over here than over here. Does that make sense to you? They're going to be traveling down this wire, right? So the current through A is going to be bigger than the current through B. Does that make sense? Because like we said, I don't know, like if the battery was your home and you get to come back home and there's only two classes that you can take in high school, both classes will result with you getting the same diploma and going to the same college. One of those classes is physics and the other class is art. Which class would you have taken? Right? Okay, so some of you, now the interesting thing is, please notice in the analogy, some of you, surprisingly, still said physics. But most of you said, oh my God, art, I would have taken art. Right? So even though there's an easier path, some people still want to take the harder path for whatever, because it's less crowded. The example that I always gave was if these are movies, right? And if the movies cost $5 to get in and $10 to get in, which line would be longer? The 5. More people are going to go through the 5. I would rather pay the 10 because then I don't have to wait in line. So it's kind of like that. So there's going to be more charges going down here, less charges through the other. Now, when we draw this again, oops. When we draw this again, and this is fully charged, now that it's fully charged, can you give me, I need the exact current value passing through this circuit, Mr. Brent. Once that capacitor is fully charged, how many electrons pass through that circuit per second? None. Excellent. Thank you. I depended on you to come up with that answer, and you did it. Do you see why? Once this capacitor is fully charged, look at the capacitor. What is missing? Do you see? There's no wire. There's no connection. A capacitor stops current. It shuts down the circuit. When you have a capacitor in a circuit, the only time that there is current is while the capacitor is charging up. Once it's charged, that's it. There's no more current. Does everyone see that? Right? Because the charge is coming out of the battery, where is the only place that they can go? Trini, where's the only places that these charges can go? To the capacitor. That's it. They can't go any farther. They move out, and boom. Once they've filled up this side of the capacitor, That's it. The battery doesn't do anything anymore. And then what happens is that capacitor stores some electrical energy there. Basically, honestly, what happens is this battery has a voltage. It has an electric potential. It has an ability to energize and mobilize the charges. So it gets them moving. When those charges store up on this capacitor acts like a backwards battery. Because as it stores up, it begins to push back against the battery. And when the electric potential across the capacitor is equal to the electric potential across the battery, then it's done. That shuts off the circuit. Because now the battery can't push anymore. Because it pushed as many charges as it could onto the capacitor, and then everything gets done. Okay, so at time infinity or something, then the charges are just like this. And there are no charges passing through here at all. There is no current. Okay? That's key. That's key. That when there is a capacitor in a circuit, in whatever branch of that circuit it is, once that capacitor is charged, that's it. There's no more current through that capacitor. All right. Question.